Okay. Oh, right. Okay. So let's see here. Yeah. Good. Yeah. Okay. Events. Okay. Right. Cool. Destroy window. There we go. Put my mic away. Okay. Now, I'm gonna wait with you a little bit. So let's see here. Create window. Okay. This takes a string int. Now, yeah, no, right, it's correct. Yeah. Okay. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Cool. And it returns this thing. Okay. Let's see here. It returns pointer to. Let's just keep these names. STL window. Okay. And here X. What is X? Y? The X position of the window, Y position. Centered, undefined. I'm guessing undefined is so. Ooh. Okay, that's interesting. But I'm pretty sure this is a 0. Okay. Blanks maybe. Okay. So we're gonna hard code some stuff for now, and we're just gonna hard code some stuff for now. Height and okay, yeah. This is it? No, the X position of the Y. Is it actual? Because like, what are these things? If I had to guess, I mean, if it's an integer, I'm guessing it's like negative. We'll hard code these for now. Why not? Okay. All right. Let's see this thing. Title. And let's just go like this. And then let's see flags. Okay. Yeah. Again, well, we're gonna have to like hardcode this, and we can make it. Obviously, we would want to have some of these settings, but I'm just gonna. Okay, cool. There, Vulcan. Okay, cool. Boink. Let's just grab this. Cool. Where are we? Go back. Cool. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, cool. Just destroy window. I think it's gonna take this thing. Yeah, exactly. STL window. There we go. Oh yeah, mustn't forget that. I believe I put that into the to-do. Okay. So window. There we go. Cool. Okay. All right. Let's see here. So, oh yeah, we're gonna need, and define, and this window is an opaque, yeah, opaque type, yep. Cool. So what we're gonna do is, we're going to, no, there we go. I'm gonna take this and, there we go. That's how you create an opaque type, I'm pretty sure. You can actually look, I've actually already created some time ago STL binding, so we can sneak peek how I did it for now. I've actually used oh yeah, it's quite a lot. I've actually used a neat macro. We're gonna look at that later on. But let's see here, and some neat macros for creating these, like, what do you call them, enums and so on. But yeah, exactly, this is how you do it. Yeah, cool. Smart double check that I remember correctly. Cool. That's oh, we can keep that there. That's fine. Okay, and we'll create a macro for this too. We don't have to do all this stuff every time. Okay. All right. So now technically we don't actually need to have this, but it's a good. It gives us a runtime check that you're not accidentally passing the wrong. It's like a dynamic typing, that you don't pass the wrong pointer type. And when you print it, you can see exactly what type it is. That's good for debugging, but you might just want to do like that, and then it will just be a 64-bit unsigned integer. That's overhead and all that, but I think this is fine. Okay. So let's see. We don't need this. But you know what? Actually, here's what we're gonna do. Show me this, and then we'll do this. And we'll take you, put you there, and we'll just do that. There we go. We're not using this, so get rid of that. Cool. All right, and in here, so yeah, okay. Foreign import. And then let's borrow. Let's just copy this thing. Okay, and this thing is Cool. Cool. Oh yeah, right. So window, and it's, let's see, foreign import data. I'm pretty sure this is how you do it. We could do this even. Might actually not be. No. Let's see, and unit, of course. There we go. Okay. Now, this is also interesting. This thing can return a null. So I think we might actually want like a, yeah, we do want a pointer type actually. Let's do, I'm curious how, I know Haskell has pointer types. Oh yeah, let's do the same thing. And it's a module call pointer. No, let's go to this thing. And it's in, okay, module call pointer. Okay, cool. So, let's see here. Okay, fine. I'm guessing, yeah, foreign import data pointer. Sorry, no. It's like this. Okay. Yeah. We're gonna need to add some utilities for that. Checking for null and so on. Okay. So you awesome. Cool. Just a little bit curious. I wonder, is this in video? Okay, cool. So we'll keep it the same. Awesome. Pointer, cool. And okay. I wonder, we should handle the Boolean there. That's important. It's important that we handle that. So yeah. How the hell do I okay, so yeah, I think we do want some crash mechanism. Yeah, I think so. Okay, we're gonna look at that. Because I do think we want exceptions for. The way I see exceptions is I think you should have exceptions for coding errors, and you should, but user errors should not cause crashes. That's how I see crashes. I don't know if there's I don't know if I could. It's probably just superstition or like something I've landed in. It's not justified. I don't know if there's a good reason for it, but that's sort of how I feel about it. But I'm open to be convinced otherwise. But I mean, it's a good question of if like this thing returns false, is that a coding problem? Is that like I think where did I put? I think this is probably correct. This is like a developer problem. If like, yeah, if this is not here, and if the user has gone in and switched this out, I mean, that's like, I mean, you're on your own at that point. Like that's not. I'm not giving you, like, I'm not gonna put in effort into putting like a graceful handling of like, oh well, what if this thing isn't there? I'm delivering this to you and I'm expecting you to have it. I think that's fair. Maybe I'm wrong about that. But okay, but then it's an interesting question of like, no, I actually, so this would need a little bit more graceful handling. We need to check for this, and then we need to print out with get error what went wrong. Let's actually, okay, so we've done this. We don't know if this works yet. Let's actually do that real quickly. Let's do this one. Doing get error. Let's get rid of these. Yeah, we can keep this. No, actually, you know what? Let's put it. I don't know. Let's put it there. Whatever. There we go. Okay. So, and this is an error. Okay. Might as well. Means I don't need to make any decisions. Error. Okay. Okay, cool. Alright, this thing takes. So I'm pretty sure you actually can return a string, and I think it will be null terminated. Okay. Wait. I think you can do this. I'm worried now. Actually, there's a question of ownership here. Returns a message with information blah blah blah, or an empty string if there hasn't been an error message set since the last call. Okay. The message is only applicable when an STL function has signaled an error. You must check the return values of STL functions call. Determine when to appropriately call STL get error. Remarks is blah 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 blah. STL will not clear the error string for successful. You must check return values. You must check return values for failure. Wait, what? You must check return values for failure cases before you can assume the error string applies. Wait, I'm sorry, what? Okay, it's internally allocated. It must not be free by account. Okay, that's good. That's good. So, what happens if I do this? Because I mean, will ChezScheme copy it? Whoops. That's not what I want. This. Let's see here. Okay. no, that's okay. Wait. Oh. Okay, so we have to. Okay. Result. Result type is similar to the with the addition of void type. In general, the type conversions are the inverse of. No error checking is performed on return since the system cannot determine whether a foreign result is actually indicated. Particular caution should be exercised with the result type schema object, double float, double single float and float. Really? Oh, that's interesting. And the types that result in the construction of byte vectors or okay, let's see. And the types that result in construction of byte vectors or strings, right? Since invalid return values may lead to invalid memory references as well as incorrect computations. Let's see. I'm just curious about this. Oh, that's interesting. Let's see, string. There. Okay, UTF-8. Yeah. Okay, so we have UTF. The result is interpreted as a pointer to a null terminated sequence of 8-bit unsigned characters. Well, if the result is a null pointer, false is returned. Otherwise, this okay. Otherwise, this means let's see. Does it? I mean, is it? The question is, does it copy it? So okay. Let's see. It's interpreted as a pointer to a null terminated sequence of blah blah blah. If the result is a null pointer, otherwise, sequence of bytes is stored in a freshly allocated. Okay. Otherwise, the sequence of bytes is stored in a freshly allocated byte vector of the appropriate length, and the byte vector is returned to scheme. Okay. If this was not, otherwise, the sequence of bytes is converted into a right scheme string, as if via UTF-8 string and the rest string. Okay. I'm gonna assume it's a little bit vague and ambiguous here, but I'm gonna assume that this works the same as this. It's basically, I mean, it copies it. The sequence of bytes is stored in a freshly allocated byte vector, because like, how else would you do? I mean, I guess actually there's there's one thing you could do actually. This has some overhead. There's actually one thing you could do. You could actually just return. I don't know if I'm being silly, honestly, with like yeah, I might be. I'm probably being silly here, but like what you could do is you could just return the char pointer, and then have actually, you know what, and let's do that, and then we can make a different decision. But also interesting, because it can return false, so it probably should return a maybe, I think. Yeah, maybe. So we need a maybe. I actually don't remember exactly how a maybe is printed. So one thing that's kind of neat that I've been thinking about is also that do we like we could create a show class, but strictly speaking, we don't need it. We don't need a show instance. So let's see. Let's print line A. But yeah, maybe I don't know. Maybe honestly, let's see, what are we doing? Okay, you know what, here's, okay, there's some things coming up now. This is exactly why we're doing this, because now the work is driving what we want to implement. So what we want, okay, am I overcomplicating this? Because we do want a debug. Okay, let's do it. Okay, there's some yak shaving going on here. Debug, and let's just do trace the purse. So now super quickly also, because like I don't want like a partially correct no, okay, yeah, this is not correct, by the way. Okay, let's do this. Let's comment this out and put that to the side. Trace. Okay, we're going to, okay, there's so much stuff here now. This is not, should not be doing this. Should not have so many things in the air at the same time. Okay, so what I'm going to do is I'm gonna run this. Okay, it runs, and now we need to actually include these. Video run. Right. For oh, really? Module 4 was not found. What? Oh, it's right there. No. Actually, also interesting thing. These should be probably like down there. Honestly, cool. That yeah, that works. Great. So let's see. Oh yeah, and I'm gonna put trace, and let's build this some. Yep, run. Cool. Okay. So now here, so this is interesting now, because okay. We have there already is a trace here, so or maybe actually just is there a log? Yeah, there's log. Let's call it log instead. And let's just do right, let's do hello. Actually, even let's do this for now. We're gonna make it better. There we go. Okay, cool. Oops. Log, and now I want it. And here's the thing. Yeah, like that, right? Yeah. Yeah, just return it. Cool. We might do some more interesting things. But let's start with this. Maybe do this actually. DBG. I think that's better. Cool. Okay. So we don't need this right now. And we can put this on sim. Why not? Okay. So we got this thing called DBG, and I'm sure we will want like a little string as well. But first, what I'm going to do is I'm going to do something like there we go. Cool. Trace. Why not call it debug? Jesus Christ. Debugged. Why not call it debug? There we go. And yeah, I mean, I guess, yeah, well, there are lots and lots of cool things you can do. Like you can have it pause, and we can like enter into like this whole little thing where we can inspect what's going on and then let it continue. So we can even implement a mechanism to go back. That is entirely possible. Okay. So now oh, right, because there is a debug already. You know what? I like DBG, honestly. I think it's neat. I think it's nice. It looks nice. It's short and sweet. Run. Let's see. Trace DBG world, and then this thing happens. World. Cool. And we can even do this. And it will show like a procedure, I think. It will print out a procedure. Yeah, procedure main.hello. Yep. Add data.function. That's cool. Now I'm gonna add something. Oh, or should I add it now? No, I should not add it now, but we're gonna add a to-do list. But that's gonna be a really cool thing. Oh wait, we do have a to-do, right? We have this here. DBG with line source location. This is gonna be awesome. So we're gonna do this next video, I think. Let's keep it like this for now. Yeah, okay. So I'm just gonna do this real quickly. I'm gonna take these two things. I can't commit them just yet. We're just gonna should I you know what, open file, and then just do this, and then do discard. No, we're just committing all of it in one go. I do not care. I do not care in this case. Okay. All right, let's get back to it. So the reason I wanted this thing, because I'm gonna do this data. Maybe I'm pretty sure that it's represented as like a vector. It's represented as a vector. I don't know what the formatting's gonna hold. So okay. Okay. Pure. There's also another thing. Yeah, you might wanna. Yeah, there's lots of. I know Haskell has a bunch of these, but we'll keep it like this for now. It's fine. Okay. So let's do hello. I'm pretty sure. Oh yeah. So what are you complaining about? No type class. Wait. Sorry, isn't there a pure? Wait. I think pure is in here, right? No. Can you just take me to pure, please? No? Okay. Huh. Applicative. I mean, it should be in here, right? I thought. Bind. Oh my god. Pure, come on. Wait. No, yeah, here. Applicative. Oh, yeah, of course. There we go, of course. Yeah, because it needs it. Yeah, pure does not have the index thing. Of course not. Of course. Cool. And actually, let's get rid of these. Yeah. So let's see here. Okay, so this is, yes, it's a vector and this is a symbol. That's how it knows which is which. And I'm curious, nothing, is that also a vector or is it just a symbol? I think it might be a vector just to like, no, it's a symbol. That's really cool. That is really cool. Wow. We have a way, I'm so happy I did that. We have a way to deal with symbols and assign them types and stuff. But it is, yeah, it is scoped, so you can have two types with the same sort of the same constructor. The symbol is main dot nothing. It is not that dot is not a scoping thing. That's the whole name, main dot nothing. So it will distinguish. It will see them as different. But that's cool. That's really cool. That means that we can do some neat things with that. But okay. So we got this thing. That's good. So that means that we can very easily construct these. So Haskell, I guess it's data.maybe if I remember correctly. Data.maybe. Okay, cool. Let's put it in here. First, what are you doing? What the hell are you doing? It's a file, and I don't think we need what do you call it? I don't think we need any foreign procedures here. This is fine. Cool. And now I think we will call data dot just. Oh, now we're definitely gonna wanna automate this. Lib foreign pointer blah 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 data. We're gonna need all this. So control no data maybe. Cool. Yeah, data maybe that's just cool. Great. So okay. Let's put this in there. And now what we can do is we can okay, right. So this is okay, so we're just gonna return the pointer. We're just gonna return the pointer. And we are going to so okay, so I'm just gonna run this quickly. Okay, it's good. Let's do I wish we could do this, but we can't. Ugly. Right, yeah, that's fine. But yeah, there it says true. Cool. Yay. All right. And then we'll look into how to deal with that in a moment. We're gonna implement the continuation monad, I think, and we're just gonna use that to handle some. I wonder continuation monad. Yeah. Oh, yeah, no. Okay, cool. I think we're going to use the continuation monad on top of like a monad stack, like a quantity over this. And that's going to be interesting. I have no idea how that's going to work with this and everything. That sounds interesting. I wonder if that's a problem. That's interesting. Yeah, that's super interesting. We'll see how that goes. Okay, and lost my train of thought. Oh yeah. Is it no foreign pointer? Now here, what we want is, I'm curious, how does Haskell do it? It has like these, like okay, pointer, one pointer. I'm sure there's like a way to check if it's not no point. Oh yeah, no, this is constant. Okay. I'm sorry, is there no? I know there is. Or I'm sure it is. Okay. Do they like turn it into like a number or something, or like an integer or something? like yeah, use enum, right, from enum or whatever it's called. I thought so. Yeah. I mean, I could use this, I guess. Minus the null pointer and see if you get 0, but am I blind or something? Like, no. Okay, so you have this in point. Okay, so you could turn it into what? Didn't I see that just a moment ago? Like you could turn into a, or it's just a function pointer. No, it's done. Yeah, here you go. Yeah, there you go. This you can turn into that, and then you can turn it into this. I think with like to enum, and then you can check if it's 0 or whatever. Or is this just an alias? It's a new type on an int. Okay. Okay. Yeah. So you can just course it, unless this is not exported. But is it exported? Yeah, it's exported. Okay. Okay. So yeah, you could do it that way, but I think we will just we'll just add a procedure here to check import is no. Yeah, because I'm thinking this would be the constant. Let's go is no. Boolean. Cool. Is no. So I don't know if I'm being silly, but I'm thinking that yeah, I don't know if I'm being silly creating a bunch of these things in Scheme. But okay. Or no, it's F type no. Okay, cool. So we can just I think this will work. And let's skip this. Yeah. So because the question is like, should like we could do this, or we could do int the pointer. I'm just gonna unsafe int the pointer and do like this. Not safe. It's very unsafe. And then we gotta name it as such, and then we can. Ooh, also interesting, because the dynamic type won't work. So this means that this actually won't work. So yeah, that's interesting. That's an interesting question, because if we use f-type pointers, you can, as far as I know, there is no way, because that is part of Scheme's. It's a macro. it's like a static. It has some degree of static analysis in Scheme. So if you want to create an f-type pointer of so if we go look in here, this is not a runtime identifier. It exists at compile time, but it can produce, or like it's like, yeah, it's hidden. So I think there are some runtime stuff, but it's like abstracted away. So, but as far as I know, I mean, this is you can't like reference this. This is nothing at runtime, which means that there's no way for us to. We can't do this if we're gonna treat. I mean, we could just let these be integers under the hood and let PureScript just handle the typing. But if you do that, then you can't print and see what pointer it is. And I may be wrong, but I think that's valuable, that you can debug and easily see what something is. Because, you know, if you're gonna do FFI stuff, there is a lot of trust me bro going on in your code. That's just how it is. And when you do that, you want to I don't think we're not gonna do this. We're gonna do this, and let's do that. Cool. Let's just do that. That's cool as well. Great. Yeah, that formatting is fine. Define null. Oh yeah. No, wait. How does that work? How does that work? Is that no? That's a problem. Because how would I create an f-type? That's interesting. That's very interesting. Okay, so this that's really interesting, because if I say I mean, because like if I say make f-type pointer, like this is a macro and it needs the f-type name, and it doesn't, like, I don't know what I don't know what f-type pointer I'm making. So yeah, this does not work. This does not work. Okay. One, actually, there's also a different thing I just realized. This is just an interesting question. So again, we could say, so that's one way, is to say, okay, we're just gonna let under the hood pointer's gonna be just, you know, integers, and then we're just gonna say, and then you can create no pointer. However, it's an interesting different thing I just realized also is that this is actually not safe, because not all pointers are allowed to be null. So you could say that actually if you have an interface, an API, and there's an argument that can expect a null, that actually you need to treat that in that specific case differently. So I would just claim that we don't want to do that. Now I just realized another thing. Maybe we don't even want this. Am I being? Is this stupid? I'm thinking we don't even want this, because I mean, it's like, is it or is this just an arbitrary choice and I'm getting into analysis paralysis here? Because we could just actually, no, that's interesting too, because like if we know the API can return and all, why not cast it into a and you know, you might wonder why even have this, but no, this property of values having this. Okay, so instead we're going to check for null here, and then we're going to return a maybe instead. So okay, actually I just realized we can just do this. Because here, okay, but sorry. No, of course, no, this is, we can't do this. We have to have, because it's not returning false. If it's null, data may be nothing. Else just result. Cool. Cool. Yeah. Cool. So okay, now you can't even invoke this if you got no. That's awesome. And in this case, actually, I just realized also, actually, in this particular case, this should probably be an either, because we need to do the get error thing. But okay, let's okay. So we don't need this whole thing anymore. This is fine. Yeah, great. Oh, okay. Lots of stuff. So let's go. S3. Oh, sorry. Is the video not? Yeah, it's there. Oh, because maybe I haven't. Sorry. And of course, you are expecting some. There we go. Hello, window. Let's just go like this. And here, oh, the type is wrong, but did I call it a CL3 window, by the way? Did I do that? Oh, I think I called it window. Yeah, window. It's prettier. Data, maybe. Cool. Now it's gonna say, yeah. Oh, that's also true. Now it's gonna say I can't. Yeah. Cool, because this type is wrong. Oh yeah. Oh. Oh, this is not correct. Let's just do that. Cool. And I don't want that. Great. Okay. Cool. Case of just start with this, see what happens. And oh yeah, no, let's also do, yeah, whoops, why won't, okay, I'm sorry, because like it's called it's just your video, right? Yeah, okay, it doesn't give me, boo, okay, no, there we go. Okay, I want you to just destroy this thing immediately. Cool, let's run this. Okay, now cool, F-type pointer, woo, and that's the pointer right there. That's awesome. Nice. Okay. Hi, hi, hi. Hi, hi, hi. Lots of stuff here. We didn't even touch this yet. Let's do this first. Let's put you there and let's get you back. Cool. Source files. Yeah, I was gonna put all of you. Pointer. Yeah. Oh, we didn't even do this. Yep. Did I put you? See, I put error in here. STL 3. No, that's good. Cool. We'll get to this. I think we'll do this in the next video. Grab window, destroy window. Great. Grab window, destroy window. We're not using this. And yeah, let's keep this thing. Cool. Cool. Yeah, I'm not tracking this. Let's put in to do there. I don't want to. Can you? Yeah, whatever. There we go. Cool. I don't even know why I keep this, but okay. All right. Version, let's just call it that. That's fine. Cool. All right. Awesome. And let's look. We done this. This is gonna be so much cooler. But yeah, okay, that's good for now.